The electromagnetic spectrum. You see, wire telegraph is a kind of a very, very long cat. You pull his tail in New York and his head is meowing in Los Angeles. Do you understand this? And radio operates in exactly the same way. You send signals here, they receive them there, and the only difference is there is no cat. Albert Einstein. At this stage, we don't need to know the ins and outs of how electromagnetic waves work. That is for a different lesson. However, all modern communication depends on manipulating and controlling signals within the electromagnetic spectrum. Here we can see the spectrum ranges from extremely low frequency radio waves of 30 Hz, with wavelengths nearly double the Earth's diameter, to high frequency cosmic rays of more than 10 million trillion Hz, with wavelengths far smaller than the nucleus of an atom. Although the electromagnetic spectrum represents an enormous range of frequencies, not all the frequencies are suitable for human communications. At the very low end of the spectrum are signals that are transmitted over 30 Hz, i.e. 30 cycles per second. Very low frequencies travel much farther than higher frequencies before it loses its power. At the high end of the spectrum, signals travel over a band of 10 million trillion Hz. This end of the spectrum has a huge bandwidth, but its own set of problems. The waveforms are so minuscule that they are highly distorted by any type of interference, particularly from environmental sources such as rain. In addition to the faster bitrate, the more power is consumed. Because of the problems with very low and very high frequencies, we primarily use the middle of the electromagnetic spectrum for communication, the radio, microwave, infrared, and visible light portions of the spectrum. We do this by modulating the amplitude, frequencies, and phases of electromagnetic waves. Each of the communication bands offer differing amounts of bandwidth, based on the range of frequencies they cover. The higher up the spectrum, the greater the range of frequencies involved. Here we can see an example of a few in everyday use. So to summarise, the very low frequencies used things for submarines and wireless heart rate monitors, through to extremely high frequencies for radio astronomy and high-speed microwave. This graphic shows where the many of today's devices are concentrated. This gives the best bandwidth to range ratio and is known as the sweet spot.